So actually, what I'd like to start out is extra credit. So here's the deal. In your notes on Friday, we did 2 problems right before we quit. And the two problems for extra credit today, for 10 points extra credit, you're going to hand these in, but these are just like we did in lecture. So you can use those as a template. And so kind of turn these in for credit. I'll let you get a head start, and then I'll start to kind of do it on the board up there too. Anybody need to borrow a calculator? Phones work. Smartphones work. So you'll have something very similar to these on your test. Feel free to work together or look at your notes. But like I said, I am going to kind of go ahead and start to do them up here too. Because they're fun. Everybody loves these things.
It's 18.2.
Yeah.
And you'll need to use a periodic table.
Yeah, how many moles? Okay.
I have all the weights memorized of all of them.
Do you?
Yeah.
That's
I'll look
cool.
at the periodic table.
That's sweet. Yeah. It can come in handy. If you're on a deserted island, kind of keep you entertained.
So leading zero there, a significant figure. That 0 after the decimal.
0 after the decimal is, but
It is.
a 0 before the decimal is not. Oh, wait. 0.02 before that would be.
So is
Yeah.
that,
No.
that's not a significant figure?
No.
Did you get to where that one 8?
Yep.
Okay.
I got a different number for the grams per mole. I got 268.
That's what I got.
Thank you. Thank you. I did too, well. 268.22.
Mm-hmm.
I don't know how I wrote that down. Thanks. It saved us some time.
So when do you put all our extra credit in the grade book? Is it in it now? Or
No.
do you wait?
If what I've been doing is if you have like a missed assignment, I've been kind of putting them in as we go, kind of. But if you have like, oh, you got 8 out of 10, I haven't been topping off your 8s. But I have been kind of keeping up with the fully missed ones.
Okay.
He was asking about extra credit. Have I been kind of keeping up in the grade book with it? And this semester I'm kind of just, if you miss one and I've got 10 points over here, when I do a test, that's when I kind of update. I'm like, okay, well that 10 points needs to go here for that missed one. This needs to be fixed. All right. Very good. Now we're ready to do it. Calculation. The first term. Or 1. Goodness gracious. 260. Cancel. It's grams. Three sig figs.
Trace.
36 things.
Is that what you guys got?
Yay!
Yay! Chemistry problems, aren't they pretty? Oops. Okay, so we are going to go ahead and do the. There was one problem before your. There was one problem before your assignment slide, and we're going to go ahead and look at that right quick, okay? So this is a little different, okay? Notice, I tell you right up front, we're going to have to use Avogadro's number.
Yay!
Yay. Because it says how many molecules is in this given mass of butane, and it gives the formula for butane is C4H10. So how many molecules? Downright molecules, not moles.
We had a problem like this in our homework that we did.
That was due?
Yeah,
Oh, okay. Okay, I'll have to look at that. Thanks for the heads up.
it was like the last
It's
one.
51 on,
Or yeah, 50.
Okay.
how many molecules are in?
Ah,
Not bad.
well, that one I won't be too harsh on. Because I hope, did you use Avogadro's number, those people who did number
Yeah.
51? Sweet. Excellent. So to work this, we are basically going to knock out the molar mass, okay, of butane. And just like you did for your extra credit this morning, it's going to be 4 times what carbon weighs, which is 12.01, plus 10 times what hydrogen weighs, which is 1.008, rounded to 2 sig figs. Okay, so the molar mass is 58.12 grams per mole. So what's our first term going to be?
1.92 grams.
Yep, 1.92 grams over 1. Perfect. So if we put 3.21 grams of methane over 1. And like I did on my answer key, I like kind of unpacking this molar mass. That means 58.12 grams for this compound for 1 mole of these molecules, 1 mole of molecules. Okay, so do we want to use it like that, or do we need to flip it? Need to flip
Is
it.
there a big difference in the fact that the book says 1.01 for the weight of hydrogen?
Yeah, 'cause that's what I've used for like all.
Yeah, me too.
That's fine, no, that's fine. And I tried to kind of tell you that actually, I like this for hydrogen, but your book uses 1.01 for hydrogen. This will be, the 1.008 is a better number, does that make sense, than the 1.01. But if you definitely use it for your homework, that's fine. Or even on a test, but on the test, you're gonna get that black and white periodic table that has 1.08. So either way is fine. Very good. So we're going to put that over 1, and that will get us, if we use the flipped version of the molar mass like that, grams will cancel, we'll be left with moles. Okay, and I already told you we're going to use Avogadro's number here because we're not after moles, which is wonderful, we're after molecules. So we know that 1 mole of these molecules is 6.022 times 10 to the 23rd molecules. Does that make sense? So here we want moles to cancel, and we want to be left with molecules. Okay, so where does Avogadro's number go? In the numerator or the denominator? In the top or the bottom? In the numerator, exactly. So if we go ahead and add a third term, which it's going to have to be kind of wrapped around on my slides, we add 6.022 times 10 to the 23rd molecules. I know it says C4H10, but that's, you don't have to put C4H10 because we're only dealing with one compound here. 6.022 times 10 to the 23rd molecules in 1 mole. And then moles cancel, and we're done. But this is one of those where you need to remember how you use scientific notation. Rounding it to fingers, how many sig figs we're going to round to? I'm liking it. 3? Yep. Okay, so round it to 3 sig figs. This is what you should get. No, that's not what you should get. Darn it. Where'd that come in from?
This is nice.
Yeah. That's, I know, that's, I got to undo that.
I'm gonna be like, nope.
Because on the next page there's C4H10 with 100. So that was the head.
My notes. Okay, somebody said, well, I better do this because it's got scientific. So 3.21. I'm going to go ahead and take it times the other thing in the numerator, which is Avogadro's number, 6.022. I hit my EXP key, hit to the 23rd. I'm going to push equals, and then all I got to do is divide it by the only number that's in the denominator, which is 58.12. That should do me. That looks more like the number of molecules. So you guys told me 3 sig figs?
Yep.
So did you get 3.33?
3.
Yay, times
Times
10 to the
22.
22nd
Hey.
molecules. That's better. Did you find the slide too, Allie?
Yeah, because there's 2 slides.
There's
with
one right after this
C4H10.
one.
Okay.
That's what was thrown. I was on the slide with the same thing, but just different masses.
So one of these could be on the test. Does that look okay? Now, just be careful in when you don't, usually students will try to use Avogadro's number when they don't need to. Okay, so if you're just going to moles, do not use Avogadro's number, unless you're given molecules, which would be strange. All right, I guess it's possible. Okay, so say my next slide. So can you find this slide next? I mean, this should be after your assignment slide,
Yeah.
right?
Yeah.
Okay. I hate spiders, by the way. So, how would you get, if you guys know that spiders have 8 legs, if they haven't gotten in a fight or anything. And so, if they have 8 legs and you have 26 spiders, how many legs do you have? You take 26 times 8, right. And actually, what you did was to use the 1 spider is equal to 8 legs as a conversion factor. Okay, 1 spider is equal to 8 legs. In other words, 8 legs are in 1 spider. And then, actually, if your first term is 26 spiders, then you guys multiplied it times 8 legs per one spider. Your spiders canceled, and you were left with legs. Okay? So, by the way, those are both exact numbers, the exactly 26 spiders and exactly 8 legs in one spider. So actually there's no uncertainty brought. So
no rounding.
No rounding. Thou shalt not round legs. Okay? So 208 legs. Yuck. That's not good. Well, we're going to apply that kind of concept to compounds. So there's a compound called carbon tetrabromide. It has 1 carbon atom and 4 bromine atoms in one repeating unit. By the way, if you find carbon on the periodic table and bromine on the periodic table, they are both nonmetals, molecular compound, right? Okay. So you're asked now not how many moles of CBr4 there are, but how many moles of bromine atoms there are. How many moles of bromine atoms? Not how many bromine atoms, but moles of bromine atoms. And it's kind of like in this case, the spider is your CBr4, and your legs are your 4 bromine atoms, right? So you guys would tell me, just looking at the formula or for carbon tetrabromide, that in one CBr4 molecule, there are 4 Br atoms. It's kind of like the legs of a spider. And we're going to actually use that equivalency statement, okay, as a ratio or a conversion factor in a minute. But let's scale it up. Instead of, if you had 1 dozen CBr4 molecules, do you buy this, that you would have, let's see, 4 times 12, that many bromine atoms? So you'd have, if you had 1 dozen bromine molecules, you would have 4 dozen bromine atoms. Well, scaling that up even further from a dozen to a mole, if you had 1 mole of CBr4 molecules, you would have 4 moles, which is a lot, of Br atoms. So we're going to pick on the bromine, but throwing carbon in there, the little subscript next to carbon is 1. So of course for every 1 unit of CBr4 you have 1 carbon atom. 1 mole of CBr4, 1 mole of carbon atoms. Okay, so there actually is the conversion factor we're going to use to get from the link, I should say, that we're going to use to get from moles of CBr4 to moles of bromine atoms. So that's the last thing we're going to do. So to work this problem, it's going to look very similar. We're going to go from grams of CBr4 to moles of CBr4. And you guys have been you did that this morning, right? We're going to use the molar mass of CBr4. And then we're going to go from moles of CBr4 to all the way to moles of Br, yep, using this thing right here. That's it. Using 4 moles of bromine in 1 mole of CBr4. So here's how this one looks. I forgot I had on my notes how we do this. So we need the molar mass to go from grams of CBr4 to moles of CBr4. So the molar mass, we need the periodic table. So we take 1 times the decimal number for carbon, 12.01, plus 4 times the decimal number for bromine, that's really heavy, 79.90. Round it to 2 decimals, we get 331.61 grams per mole. And again, when I do these, especially in this class, I would write 331.61 grams per 1 mole. And I might even say grams CBr4 per 1 mole of CBr4 this time. So the first term is going to be the mass of the CBr4, 1.92 grams of CBr4 over 1. So the molar mass, does it kind of look like we need the flipped version of the molar mass? Because we need grams to cancel, moles on top. So the next term is going to be the molar mass of CBr4. 1 mole CBr4 for 331.61 grams CBr4. So grams have canceled. Now we need moles of CBr4 to cancel, and we need to be left with moles of Br. So that's why it looks like this. 4 moles of Br per 1 mole of CBr4, excuse me. And that's it. So when you have multiple things, ratios kind of multiply by each other, we've been talking a lot, and I think you guys are doing pretty good. Remember what that means is, I kind of think of it as one big denominator, or one big divisor, 1.92 in the top, a 4 is also in the top, and 331.61 is in the bottom. So did you guys get rounded to 3 sig figs? 0.0232 moles of bromine atoms.
Yeah.
Okay. This is just kind of a variation, taking it a step further, getting to 2 moles of individual atoms. So this is kind of a slide to remind you, this actually will come into play when we start talking about what we call stoichiometry calculations after your test on Friday. But oftentimes you have different compounds going on in there. In this case, we're just dealing with one compound. But sometimes you need to be explicit, okay? And explicitly label what is what in terms of grams of what. So that's what this is talking about. Okay. So we already did this one. Did it look right? My slides are so strange. Oh, no, we didn't do this one. Oh, can I just leave it up there for now? It's a little different. Instead of CBr4, it's CH4. To me, it's very similar. Sorry, no, it's not CH4. Dang it. Instead of CBr4, it's C4H10. Final answer. Okay, butane. But this is I do have some homework to assign, and they're very similar to the CBr4 and the C4H10. The thing that's different up here, you see the first line is to get the molar mass of C4H10. So we take 4 times the mass of carbon, 12.01, plus 10 times the mass of hydrogen, 1.008. So the molar mass for that compound is 58.12 grams per mole. In this case, we are trying to get to moles of carbon atoms. If you read that statement, which I just blew off, moles of carbon atoms. There are 4 moles, again, of carbon atoms per 1 mole of C4H10. That's what kind of threw me off. Molecules. So we take the mass of butane, 1.92 grams of C4H10 over 1. The next step is to get to the molar mass, to get to the moles of C4H10 using the molar mass that we got above. Again, anytime you want to go from grams to moles like that, we're going to use what I call the flipped version of the molar mass. But I don't memorize things. I just look at it how I need to flip it or not. So grams will cancel. We'll be left with moles of C4H10. And then the last ratio there is to go ahead and get it. Oh, now I see. The third term, not the last term. The third in 4 terms is to get it in terms of moles of carbon. So we put 4 moles of carbon atoms per 1 mole of C4H10 molecules. And then last but not least, I see now instead of moles of carbon, we wanted grams of carbon. So once you have moles of carbon, and one of these won't be on your test, but the other one might be. One last thing we got to do is we go back and look at the decimal number for carbon, which is 12.01. And what that means is that there are 12.01 grams of carbon in 1 mole of carbon. So then moles of carbon cancel, we're left with grams of carbon. Looking like, I bet you would tell me 3 sig figs. So the grams of carbon is 1.59 grams of carbon. Thank you for your patience.
Assignment slide.
Assignment slide. Yeah, so these will be due for like real credit. There's 2 problems listed there, right? Okay. And so actually, again, to kind of take a look at what they look like, these are screenshots of 63 and 67. Okay. Let's make 67 for extra credit, since I kind of butched that in class. For 10 points extra credit. But it's very doable. And if we take a look at this top one up here,
Chlorofluorocarbons.
what's that?
I said all of the chlorofluorocarbons.
Many of them.
I just like saying the word chlorofluorocarbons.
Okay, so this is the number of moles of carbon in each sample. So here's the deal. Your hint here is no Avogadro's number. Do not use Avogadro's number. And so if we look at the first one, these don't look as bad as I thought. And you don't even have to get the molar mass. Let's knock out the first one together, okay? Let's look at A. What the heck? Okay, so basically, the number of moles of carbon in CH4 given, this is going to be first term, 2.5 moles CH4. Okay, so I'll go ahead and set it up for you without the numbers. We want moles of CH4 to cancel, and we want to be left with moles of carbon. So the number, and you can actually use fingers for this, tell me what number goes in the purple circle. Purple circle. Fingers. I heard 4. Is that right? No. What's another? I heard a 1. Is that right? Yeah. That threw me off too, because we've been doing 4s. Does that make sense? And you're done. You were totally done with that one. And I'll post these on my Twitter feed, okay? No Avogadro's number. And no molar mass, dang. So for this one, don't even have to use molar mass, because they're all in moles already. You had to use molar mass when it was given grams, okay?
Oh,
When it was
wow,
given
yeah,
grams.
you're right. It's
I
just
know.
number of moles in moles.
I know.
I literally just did the molar mass on my paper, like, yeah, I'm good. And then I was like, nope.
But for these, again, no Avogadro's number. Poor Avogadro. Oh my goodness. Yeah, that's right. Avogadro's number. But you need to use molar masses. And the reason is you are given, instead of moles, you're given grams. So basically, let's kind of diagram, and again, these are for 10 points extra credit. Let's say how that one would go. So basically, you're going to have 38.0 grams of CF2Cl2. Okay, and we're going to go to moles first. How are we going to do that? Exactly, the molar mass.
So on number 63, 2.5 times 1 is 2.5, so the answer to that is 2.5 moles.
You're right. Good
But-
point.
H doesn't weigh
So
anything.
H weighs nothing then?
The age, that wasn't the question. There
No, I
are,
know, I
Yeah,
just
but there's
thought it was
2.5
weird.
moles of,
there's
Of
2.5
CH4.
moles of carbon. 2.5 moles of carbon.
So in
And
2.5 moles
how many moles of
CH4,
hydrogen would
there's
there be?
2.5 moles
Mhm.
of
that
carbon.
means there's 0 moles of hydrogen.
Nope. For hydrogen, you would swap out that one for a 4 moles of hydrogen in 1 mole of. See how that goes? No? So, like, if this was instead of carbon, if it was hydrogen,
Yeah.
okay, it would look like this. So it would be 2.5 moles of CH4 over 1. And if we're after hydrogen, we're going to put 4 moles of hydrogen. We switched what we were after per 1 mole of the compound, CH4. And actually 4 times 2.5 is
And
10, giving 2 sig figs 10 moles of hydrogen. And actually that, Aaron, leads us into one of the things we're going to cover in the next part, is you can take a compound and kind of break it apart, talk about the carbon first and talk about the hydrogen next. And you're right, it can't have 0 hydrogen, and this is how many moles of hydrogen it has. Yeah. Very good. So down here, you guys told me we're going to go from grams of CF2Cl2 to moles using the molar mass of the compound. CF2Cl2. And then we're going to go from moles of the compound specifically to moles of chlorine. Moles of chlorine. What ratio are we going to use there? It's in the formula, right?
would be chlorine over CF2Cl.
Right.
Have any, like,
So it'd be 2 moles
Yep.
of chlorine, yep, over 1 mole of CF2Cl2. Perfect. So we've got moles of Cl. How did we get from the last step, like in the problem we just did, how do we get from moles of carbon to grams of carbon? How do we get from moles of Cl to grams of Cl? Because that's what we need to do. Remember? What's that?
You start out with like the 38 point.
No.
Oh, no, you're going.
You find like on the periodic table the
Yep.
mass.
Yep.
mass
You
of-
find out on the periodic table the mass of chlorine. Exactly. And so the molar mass of it's like 34.35, 35.45. Very good. We got that one memorized. So actually, you're going to use the molar mass of Cl, which is 30. Would you say 35.34? 35.45. So that's how you're going to knock that one out. That one's very similar to the grams of carbon in C4H10 that we did. Okay, those are for extra credit. Any questions? I know.
So can we set that one up so like we see what it looks like working it out?
Well, I think not in class. You can come by my office, but I think, because I don't want to take the time to knock out the molar mass of CF2Cl2. That's kind
Oh,
of
that's 85.46.
okay. So 38.0 grams CF2Cl2 over 1. And we have a molar mass up here. Say it one more time.
85.46.
85.46 grams of CF2Cl2. That's the molar mass per 1 mole of your CF2Cl2. Okay, that's we did that first step. I'm kind of doing it in green right here. It's kind of hard to see.
Yeah, I lied, never mind.
What's that? Now we're ready.
Molar mass, when I put it in my calculator the first time, came out to something else.
She just forgot one of the chlorines.
Yeah.
So instead of that, what is it?
120.91.
Yeah.
Okay,
Sorry.
that's okay. Appreciate you. 120.91. All right. Then we have 2 moles, because that's the little subscript 2, of chlorine and 1 mole of CF2Cl2. So things have canceled so far. Looks like our grams have canceled. Our moles of the compound have canceled. We're left with moles of Cl. So now the last thing we need to do is from that, you guys told me it's 35.45
Yeah.
grams of chlorine and 1 mole
72.
chlorine. And we're done.
76.
Okay.
So what'd you get?
76 divided by 12.
Did anybody do it? Or is that's good enough? Okay,
Figure it out from there. I just wanted to
Good.
see
good. All right. So we are going to go ahead and go to the next part. Parts is part. Parts is parts.
I thought it was done.
Yeah. It looks like we might, we'll get through, I think we'll probably actually get through percent elemental composition right now. And then that just leaves empirical formula for Wednesday, maybe a little bit of review for Wednesday. We'll see what that looks like. So this actually goes back to what Aaron said with, when you have a compound that has carbon and hydrogen in it like that, you need to be able to kind of think of, at times, the way I think of it is think of them kind of as separately. It's almost a mixture. Compounds are a mixture of elements. Okay, so percent elemental composition problems are not too bad. We talked about weight percents. Remember the eggs? Okay, the egg has 3 components, and so you can have how much weight percent is brought by the yellow, how much is brought by the white, and how much is brought by the shell. That's exactly what we do with these problems, but instead of those kind of components, it's the elements. Okay, so it's really not too bad. And so we'll do one example. We'll pick on acetone. So acetone has 3 carbons, 6 hydrogens, and 1 oxygen. Acetone. So the formula is C3H6O. This is not one that you'd need to memorize, right? So just like your egg, we needed to take a mass of the whole egg, right? So kind of like that, we need to get the mass of the whole compound first. So the C3H6O, we would take 3 times carbon's mass, 3 times 12.01, plus 6 times how much hydrogen weighs, 6 times 1.008, plus 1 times how much oxygen weighs. So per 1 mole of compound, it weighs 58.08 grams per 1 mole. So if we kind of, as we say, and we do this a lot in other chemistry problems, if we say I've got 1 mole of the compound, I have 58.08 grams. So if I have 1 mole of the compound, of that 58.08 grams, 3 times carbon's mass is the mass the carbon brought. So the mass that carbon brings is 3 times 12.01 grams. The mass that hydrogen brings is 6 times 1.008 grams. The mass that oxygen brings is 1 times 16.00 grams. So now it's, again, back to what you did in the lab. Basically, what you're going to see on the next slide is to take 3 little division problems. I think these are kind of fun. And for our 3 division problems, we're basically, for carbon, we're going to take that number, and we are going to divide it by that number. Why? Because that number is our total. Okay. For hydrogen, okay, we're going to take this number, and we're going to divide it by, again, this number. And last but not least, for oxygen, we could get it by difference, okay, but we're going to take that number, and we're going to divide it by that number. That's it. So here we go. The weight percent brought by carbon is 3 times 12.01 grams of carbon divided by 58.08 grams of acetone. We have to round according to what we're limited here. Looks like 4 sig figs. Oh, by the way, when you do that division, that will actually give you what we call a mass fraction. To get it parts per 100 or percent, you have to take it times 100. And I usually go ahead and even throw in this term right here. I usually say it's times 100%. Okay. So 4 sig figs, weight-wise, carbon brings 62.04% by mass for acetone. Hydrogen's very similar. So we said it's the mass brought is 6 times 1.008 grams of hydrogen per, again, that 58.08 grams for the total compound, times 100%, rounded to 4 sig figs, 10.41% by weight is hydrogen. This is a good example. Do you see where, and I definitely, as you might imagine, your homework's fine when you use the 1.01 for hydrogen. That's just great. But the thing here is if we use 1.01 in our calculation, that would have actually made us so that 3 sig figs in 1.01, that would have limited us to only 3 sig figs in our answer. So that's kind of why they say for the light elements use 3 decimals. Okay, last but not least, we said the mass brought by that single oxygen in acetone is 1 times 16.01 grams of oxygen over 58.08 grams of compound times 100%, rounded to 4 sig figs, 27.55. Okay. They're pretty good. What should they add up to be? 100%. Exactly. And I think that's what the next slide tries to kind of point out. Honestly, if they don't add up to 100%, like if they're off by, 0.05, that's fine. It's just kind of a rounding thing. So this actually will be due for credit. Not for credit. This is a gotta turn in. Okay, so I've kind of lost track, but when I get back to my office, I'll figure out what I said. So let's take a look at what this looks like. 681. So ignore the 680, but look at the 681. Okay, 681 is down here. Calculate the mass percent of carbon in each compound. Mass percent. Are they 80? There's the same one. Are you serious?
Both are 80.
I know how that happened. Hold this thought. I still got 5 minutes. 81, because I should be here. Nope. So technology is working. It's just I'm not working this morning.
You know those days.
That's not it. Let's see. Oh, it must be this one. I'll try one more time. But you guys should be able to do this one, right? Phew. Goodness gracious. Are you serious? You guys should be able to do both of these.
There it is.
I know, so I found it. So 81 says calculate the mass percent composition of each element in each compound.
So it only wants carbon for each of them?
That's 80.
Yeah.
It says, yeah, we have to do 81.
Okay, I know what I was going to do. Okay. So the assignment slide, actually, the last slide in this part says 80 and 81, right? So
No, I just said
No, it just says 81.
the last slide?
Yeah.
Silly. No.
There's this one, but the very last slide says problems 80 and 81.
Now the last slide, 80 and 81.
Oh, but it says instead of calculating the mass percent, determine the empirical formula, which we did not know yet.
Oh, okay. So here's the deal. Doesn't 80 look easier than 81?
Yep.
Okay. So do 80 for gotta do, 81 for extra credit. Okay? And yeah, I know. And they're fun to do too. So gotta do.
Falling out style.
So we do,
75% is extra credit, so I can outdo it.
What's that?
80.
So yeah, so 80 looks easier because it's just carbon, and this is all elements.
Yeah, our assignment side that we just got to said just 6.81.
Yeah. So yeah, you're gonna have to ignore that science slide. Like many slides in today's lecture. Very good. Well, thanks for bearing with me. And there you go.